Hello and welcome to another STEM in a Box instructional video. Today we're going to show you how to test all the outputs of ebot app using ebot using mblock Scratch and our ebot custom blocks. Excellent. So first thing you need to do is have your robot turned on and plugged in with the USB cable, and then you need to have the extensions, our ebot Junior extensions installed if that's the robot you've got, or the Pro extensions, and we've shown you how to do that in a previous video. Secondly, you need to have just select the mbot board in mblock Scratch, and thirdly we just need to connect the COM port. Right, so it's connected now. How do you know that? Because it's got serial port connected up the top there, and if you go to robots, it's got the green circle there illuminated. Excellent. So these are the ebot custom blocks that we're going to be using. We've tested the inputs in a previous video. What we're going to do now is test the outputs. So let's start with the LEDs, and the LEDs are on the bottom with the light sensors. There are two on the front, and then there's a string of them going around the outside. So let's turn them all on red, and now they're all red. It's RGB. If you can look up an RGB color calculator and select any color that you wish, and it will give you the RGB combinations. So there we go. I'm going to stick on that one. So I can change the proportion of red, green and blue to get any color I want. Secondly, I can have full control over the luminosity or the brightness. So if I wanted the same color, let's say I'm calling that aqua, if I wanted that same color but only half the intensity, then I would halve all of these values. So that would go to 20, 20 and 50. Well, there's no 50 there, so I just need to type in 50. Okay, so that is exactly the same color. Why? Because it's the same ratio of red, green and blue, but because it's got half the percentages, it's going to be half the luminosity. So if I hit the block, it's now the same color but half the brightness. Excellent. If I wanted only one of them to illuminate, then I can select from any of these, or I can type in a particular LED number, and they start the numbering from the left-hand light sensor, which is 1, right-hand light sensor, which is 2, the front one on the bumper is 3, front left is 3, front right is 4, and then it goes 5, 6, 7, 8 accordingly around the chain. Excellent. All right, so the LEDs are all okay, and we know that we have full luminosity control and also full color control on each individual LED from the one block. If we want to kill them all, we can just not kill them all, turn them all off, turn them all back on the way they were. There we go. Great, LEDs are check. Let's do the claws. If you have the Junior, which I'm showing you here now, then you will have 2 claws on the bumper. If you have the Pro, then you will have a claw, and you'll also have a crane, which can lift things up and down. So you can turn the claw off here or on, and the advantage of that block is it actually electrically disconnects the current from the servo altogether, so it will stop jittering and using up current when you're just telling it to do nothing. So we have claw open, so 100% is all the way open, so let's hit that. Great. Now let's go all the way closed, which would be 0% open, and it's all the way closed. Great. I'm just using all of this in tethered mode, obviously. Now the purpose of the offset is if you get a small amount, maybe 10 to 20% of extremity control with the offset, but I'd recommend that you don't really try and do too much with that. It really needs to be mechanically set up in the right place, so that if it's not, when you hit the claw close, which would be open 0, if it doesn't come in far enough, then you just need to undo the screws and then lift the claw up off the spline on the servo and rotate it round a few more degrees to whatever it is you want to be the position of the claw when you hit the claw close button, okay? Or tell the robot to close its claw. And that should be a once-off setup in construction. Excellent. So that's all good to go. So we've got open and close, and then we've got all percentages. Halfway open is 50%, and that would be halfway open. Great. Now, I don't know if you can hear, but it's jittering away, chewing up current, which I really don't want a robot to chew up current because that's energy and that's going to deplete my batteries. So if I don't actually want to use my claw, then I would just hit the, issue a claw off command, and then the jittering noise is gone and it's not chewing up any current. Great, so let's move those out of the way. Now let's have a look at the drive motors. So we've got 4 blocks. We've got your easy drive forward, drive backwards, turn right, turn left, and then a percentage. So 0 being stop and 100 being full speed. We also have differential drive, so left hand and right hand. We also have a wheel offset block, and the purpose of the wheel offset block is if the wheels motors are creeping ever so slightly when you issue a stop command, then you can adjust for it there. But I strongly recommend that you do all that adjustment in ebot app because it's far more accurate and gives you a much better result, and the robot remembers it in its EEPROM anyway. So it's best that you do it in ebot app, but you can do it here if you wish. Okay, so let's see if before I hit that, I better pick the robot up. Okay, so go forward, it's going forward. Now backwards, going backwards. Don't forget you're looking at the robot upside down. And to give it the stop would be 0. Terrific, and it's all stopped. So if the wheels, now they're not creeping because this robot's been set up in ebot app, but if they were creeping a little bit, you could issue a -1, 2, or 3 to, for an offset, +1 or -1 depending on which way they were going in the wheel offset. But we're not going to do that now. You can also use the differential drive, so that would be go forward, go backwards would be negative on the left and negative on the right. So that's go backwards full speed, and this would be turn left, 0 on the left, and that would be turn left forwards would be 0 on the left and 100, so that's turn left forwards. Great, so that's all working, and I am just going to use the wheel off block, which is really useful. It's exactly the same as the claw block. If I click that, it will electrically disconnect the wheels altogether, which is a good thing to do if you want to not use the wheels for more than a couple of seconds, because it stops it using up any current, because unfortunately the servos do use current if you're telling them to be still, because they hold their position. Great. Now, what's this wheel polarity? I would strongly recommend that you don't use it, that you set up the wheel polarity in ebot app, but if you really must, the purpose is that if you tell the robot to go forward and one of the wheels is actually going backwards, you can flip it using this block here for either the left hand or the right hand. You can flip it so that when you issue a forward command, it does go forward. But I would strongly recommend that you do that setting up in ebot app, because it's much easier, much simpler, and then it makes your coding here much simpler, because all of that setup stuff is then remembered in the EEPROM. And so I would strongly recommend that you leave that out of your code and set it all up in ebot app. Great. So that's the end of the output testing. So we've got full control of our LEDs for color, for luminosity, the crane, the claws went all the way in closed and all the way out. They were working perfectly, and we had full control over our servo motors. So all of our outputs are working perfectly. Thanks very much for watching.